Fine. Let's start. Number 10. The Antennae galaxies. There is a photograph that almost everyone who has ever opened a spacebook has seen at least once. Two galaxies, locked together, glowing in the dark like a butterfly mid-flap, with two long curving tails of stars streaming out behind them like the antennae of an insect. That photograph is real. It is happening. And it has been happening for almost 1 billion years. The Antennae galaxies sit about 45 million light-years away in the constellation Corvus. Their formal names are NGC 4038 and NGC 4039. 900 million years ago, they were two ordinary galaxies, drifting through their corner of the universe, minding their own business. Then they started falling toward each other. 600 million years ago, they passed through each other for the first time. Take a second on that. We tend to think of a collision as a single moment, a snapshot, a thud. But when galaxies hit each other, the impact happens in slow motion across hundreds of millions of years. Stars do not actually crash into other stars. There is too much empty space inside a galaxy for that. What collides is gas, clouds of hydrogen slamming into other clouds of hydrogen, compressing, igniting. The two cores keep moving. They overshoot. They come back around for another pass. The antennae are in the middle of that second act. Their cores are now about 30,000 light-years apart and still closing. Behind them, the streams of stars that got flung out by the first encounter form the two antennae. Inside the contact region, where gas is being compressed at scales that almost defy description, Hubble has counted more than 1,000 newly formed star clusters. Bright blue knots of light, each one a nursery, each one born from this fight. Most of those new clusters will not survive. Only about 10% will make it past their first 10 million years. The rest disperse, their stars scattering into the smooth background of the merged galaxy. Maybe 100 of the most massive clusters will harden into permanent globular clusters, the kind that orbit galaxies for billions of years. The rest are temporary. They are sparks, struck by the impact, and they will die before the wreckage finishes settling. The antennae will keep going. Computer models predict that in another 400 million years, the two cores will spiral in and merge completely, and what we now see as a butterfly will become a single, smooth, elliptical galaxy. No spiral arms, no antennae, just a soft, glowing ball, like every fight ever forgotten. And here is the part that should bother you a little. The antennae are what astronomers consider an early example of what the Milky Way and Andromeda will look like in about 4 billion years. Same kind of pair, same kind of approach, same kind of slow, ruinous embrace. The photograph you have seen since you were a kid is, in a real sense, a postcard from your future. The butterfly is not just beautiful. It is what we are about to become. Number 9. The Mice galaxies. There is a pair of galaxies about 290 million light-years away in the constellation Coma Berenices. And if you saw a picture of them with no context, you would not call them galaxies at all. You would say it looks like two mice, mid-leap, with their tails stretched out behind them. That is genuinely how they got their name. NGC 4676. The mice. What you are actually looking at is the first close encounter between two spiral galaxies. About 160 million years ago, they swept past each other. Not through each other, not yet. Just close enough for gravity to do what gravity does. Each one reached into the other and pulled. And out of each galaxy came a long, thin trail of stars and gas, dragged into space by the tide. These tails are made of stars, real stars with planets potentially around them, real systems with their own physics, all of them ripped out of the spinning disks of the parent galaxies and stretched out into pencils of light. Including those tails, the combined size of the pair is about 760,000 light years across. That is roughly 8 times the diameter of the Milky Way. 2 galaxies, 1 photograph, 8 times bigger than your entire home galaxy. We tend to imagine stars as anchored, fixed points, lights on a black backdrop. They are not. They are objects in motion, and they respond to gravity like anything else. When 2 galaxies pass close enough, the stars on the side facing the other galaxy feel a slightly stronger pull than the stars on the far side. That difference, that tiny imbalance of forces, is enough to stretch the galaxy. The result, given 100 million years to develop, is a tail. The mice are not going to stay this way. Simulations show that the 2 galaxies will keep falling back toward each other, pass through each other a few more times, and eventually merge into a single elliptical. The mice will become one round, featureless animal. But for the next 100 million years or so, they keep falling. Their tails keep growing. The stars in them keep moving outward, then slowing, then turning around. And here's the thing that should land. You and I look up at the night sky and see stars, and we treat each one as a fact of life, a given, something that exists, where it exists. But every single star in those long, thin tails was born somewhere else, inside a settled disk, surrounded by neighbors, in the middle of an ordinary stellar life. And then, one ordinary day, the sky in that star's neighborhood started getting bigger, and the gravity started getting wrong, and the stars around it started getting farther apart, and they all left their home and went on a journey they did not choose. That is what gravity does. When it really gets going, it takes whole populations of stars and moves them. The mice are not playing. They are running in the only way galaxies know how to run, which is for hundreds of millions of years. Number 8. The Cartwheel Galaxy. About 500 million light years away, in the southern constellation Sculptor, there is a galaxy that looks like nothing else in the sky. From our angle, it is a perfectly round ring of bright blue and pink light, with a small yellow nucleus at its center, connected to the ring by thin spokes. It does not look like a spiral. It does not look like an elliptical. It looks like a wheel. It is called the Cartwheel Galaxy, and the ring is a wound. About 200 million years ago, a smaller galaxy passed straight through the center of the cartwheel. Not close to it. Through it, like a fist through a drum. The cartwheel was probably a normal spiral galaxy before that day, similar to the Milky Way, with arms and dust lanes and a quiet life. The intruder broke through the middle and kept going, like a bullet exiting a target. But the bullet left something behind. A pressure wave. Imagine throwing a stone into a still pond. The wave moves outward, away from the impact, in a perfect expanding ring. That is what happened to the cartwheel. Except the medium was not water. It was interstellar gas. And when interstellar gas gets compressed by a passing shockwave, it does not just ripple. It collapses. It forms stars. So what we see today, 200 million years later, is the expanding wavefront, a ring of star formation roughly 150,000 light years across, expanding outward at about 200,000 miles an hour. Several billion new stars, born inside the shock front. Stars that would not have existed at all if the intruder had missed. The Milky Way, our entire galaxy, would fit comfortably inside that ring with room to spare. In 2022, the James Webb Space Telescope released its image of the cartwheel. For the first time, we could see through the dust to the structure inside. The thin spokes between the inner core and the outer ring became visible. They are streams of younger stars and gas, still in motion, still being dragged outward by the wave. The cartwheel is not finished. The ring is still expanding. The intruder is still moving away, possibly still visible nearby as one of two small companion galaxies. And here's the detail that gets me. The ring will not be there forever. Over the next billion years or so, the wave will dissipate. The gas will exhaust itself. The newborn stars will scatter into a more ordinary distribution. The Cartwheel will probably go back to looking like a regular galaxy. Future astronomers, if they exist, may look at it and see nothing unusual at all. There will be no obvious sign that a long time ago something punched through it. That is what most of these collisions are like when you really think about it. We catch them in the middle. The before is invisible. The after is invisible. The only reason we get to see the violence at all is that we happen to be alive at the moment the shockwave is still passing through. A ring this perfect should not exist. It only exists because, in some very specific past moment, something fell straight through the heart. Number 7. The Tadpole Galaxy. Imagine you are looking at a disturbed spiral galaxy. Bright, normalish, a little bent. Off to one side, you notice a small smudge of a companion. Then your eye keeps going, and going, and going. And you realize the smudge is connected to the spiral by a tail of stars that does not stop. It just keeps going, across the frame, longer than the galaxy itself, longer than anything else in the picture, until it finally fades out into intergalactic dark. That is the Tadpole Galaxy. UGC 10,214. It sits about 420 million light-years away in the constellation Draco, and the tail behind it stretches more than 280,000 light-years. To put that in scale, that single tail is roughly 3 times the width of the entire Milky Way. About 100 million years ago, a small compact spiral galaxy crossed the tadpole's path. It did not collide head-on like the intruder that made the Cartwheel. It came in at an angle. It plunged through, dragging gas and stars sideways out of the disk, like a hand brushing through wheat. Then it kept going. And it is, in some sense, still in there, embedded in one of the tadpole's disturbed spiral arms, still visible in Hubble images as a small bright knot near the main galaxy. The bullet is still inside the wound. What makes the tadpole's tail special is not just its length. It is what is in it. When Hubble's advanced camera for surveys first imaged the tadpole in 2002, astronomers saw something unexpected. Bright blue knots all along the tail. Star clusters, brand new stars, forming inside the debris field. The collision did not just rip material out of the galaxy. It compressed that material as it was being ripped out, and the gas inside started gravitationally collapsing all along the strand. You are looking at a galaxy where the act of being damaged was also the act of becoming pregnant. Those new stars do not have a normal home. They are not in a spiral arm. They are not in a disk. They are flung out into intergalactic space, drifting in a thin strand, and most of them will eventually either fall back into the tadpole or escape entirely and become part of the loose, cold population of stars between galaxies. Some of them have planets, probably. Most stars do, which means that somewhere out there, in the dark between the tadpole and the next galaxy over, there is a planet orbiting a sun that was, in a previous life, an ordinary citizen of a quiet spiral disk. And one day, the sky in that planet's neighborhood got bigger, and the gravity got wrong, and that planet ended up in a place it was never supposed to be. 280,000 light-years. That is the length of the tail. That is the distance some of those stars now sit from their birthplace. They will never go home. The tadpole will eventually shed the tail. Over hundreds of millions of years, the stars in it will scatter or fall back. There is a kind of cosmic statute of limitations. Eventually the evidence fades. But for now, the tail is still there, still glowing, still telling the story of the day a galaxy passed through and did not apologize. Number 6. Stephan's Quintet. In the constellation Pegasus, there is a group of 5 galaxies pressed close together against the same patch of black sky. The French astronomer Édouard Stephan saw them on a photographic plate in 1877 and noted that they sat unusually close together. He had no way of knowing what he was looking at. It would take more than a century to figure out that one of those 5 galaxies is, right now, plunging through the others at over 800 kilometers per second. That is roughly 1.8 million miles per hour. Stephan's Quintet sits about 290 million light-years away. 4 of its 5 galaxies are genuinely part of the same group, gravitationally bound, interacting. The 5th is a foreground galaxy, closer to us, just lined up nicely along our sightline, like the right tree in front of the right hill. The illusion is excellent. The reality is that the 4 real members of the group have been interacting for hundreds of millions of years. And one of them, a galaxy called NGC 7318b, is the bullet of this story. NGC 7318b is the intruder. It is currently diving into the group at high speed, and it is not just hitting another galaxy. It is hitting old debris. Earlier interactions in the quintet left behind a streamer of gas in the space between the galaxies. The intruder is now slamming into that streamer head-on. The result is a shock wave. Not the cute kind. A real one, made of gas, plasma, and compression, several times the size of the Milky Way. In 2022, when the James Webb Space Telescope began releasing its first images, Stephan's Quintet was one of them. The image is famous now. You can see knots of starlight, dust lanes, distorted spiral arms. But what JWST and ALMA saw together in follow-up observations in 2023 is what really matters. They watched the shockwave breaking apart enormous clouds of molecular hydrogen, the stuff that future stars would normally be made of, and rebuilding them in turbulent patterns we had never seen before. In one place, they spotted what looks like a brand new dwarf galaxy being assembled inside the shock. Let that sit for a second. In the wake of the collision, something is being born. The crash is not just destroying old structures. It is also forging new ones in real time. Galaxies are not just being smashed in Stephan's Quintet. They are also being made. The most unnerving thing about Stephan's Quintet is how casual our access to it is. Édouard Stephan, in 1877, looking at a glass photographic plate by gaslight, made a note that there were some galaxies pressed close together in Pegasus. That was the entire entry. He did not know that he was looking at a galactic train wreck in progress. He died long before anyone figured it out. The quintet has been doing this. The 800 kilometers per second, the shockwave, the molecular gas, the entire time. While humans invented radio, built nukes, went to the moon, the quintet was crashing. While JWST was being designed and built and launched, the quintet was crashing. While you and I are having this conversation, the quintet is crashing. It does not stop, ever, for anyone. It does not even know we are here. Number 5, ARP 220. About 250 million light-years away, in the constellation Serpens, there is a galaxy that looks, at first glance, like a smudge. A bright smudge. A weirdly bright smudge. If you point a normal optical telescope at ARP 220, you see what could be mistaken for a strange single galaxy with some dust lanes. Nothing extraordinary. Now point an infrared telescope at it. ARP 220 becomes one of the most luminous objects in the nearby universe. ARP 220 radiates with the kind of energy you would expect from a quasar. Almost all of it in the infrared. That is not a coincidence. That is the signature of a galaxy that has so much dust thrown up by an ongoing collision that almost no visible light gets out. Everything is absorbed by dust, then re-emitted in the infrared. We are not seeing the violence directly. We are feeling the heat through a wall. Roughly 700 million years ago, two galaxies began merging. Their cores are still visible, just barely. Two compact buried nuclei, about 1,200 light-years apart, glowing in infrared because each one likely contains a supermassive black hole and a starburst region that we would describe with words like extreme if we did not have to write press releases about it. The two former galactic centers are spiraling toward each other through a thick, suffocating envelope of dust and gas. We can see them in radio and infrared. We cannot see them in visible light at all. It is too clogged. In a region only 5,000 light-years across, that is roughly the distance from us to the nearest globular cluster. ARP 220 has produced about 200 large star clusters. 200. In a region small enough that, if you mapped it onto our own galaxy, it would barely cover the area near the galactic center. The merger has compressed the gas so violently that star formation is happening on a scale that the universe almost never gets to do anywhere else. ARP 220 is what astronomers call a ULRG, ultra-luminous infrared galaxy. The ultra is doing work. There are only a few dozen of these in our neighborhood, and almost all of them are mergers in late stages. They are the universe screaming. And ARP 220 is the closest scream we have on file. And here is the through line. Remember the Antennae galaxies, the butterfly we started with? Same kind of merger. Just earlier. ARP 220 is what the antennae will probably look like in another few 100 million years, when the two cores have nearly fused, and the gas has been compressed beyond recognition, and the entire system is buried in its own debris. The bright photogenic phase comes first. The deep, dust-choked infrared furnace comes second. What we are seeing in ARP 220 is the part of a galaxy merger that nobody puts on a calendar. The part nobody photographs for the National Geographic special. The part where the galaxies have lost their identity. You cannot tell which one used to be which, and the merged remnant just burns in a wavelength that the human eye cannot see. Imagine being inside one of those nuclei, stars packed so tightly that supernovae would be going off in your sky roughly once a year, somewhere within 1,000 light-years of you. The night sky would not look black. It would glow. ARP 220 is what galactic violence looks like when you let it stew. It is what the rest of the items on this list eventually become, if they live long enough. Number 4. NGC 7727. About 89 million light-years away, in the constellation Aquarius, there is a galaxy that, until 2021, looked vaguely chaotic, but otherwise unremarkable. NGC 7727. It has the messy, swept-back arms of a galaxy that went through a merger about 1 billion years ago and never fully recovered. There are streamers of stars curling outward. There are pockets of star formation that do not quite line up. The structure looks like a galaxy that survived something. In 2021, astronomers using the MUSE spectrograph on the Very Large Telescope in Chile pointed it at NGC 7727 and confirmed something extraordinary. There were two supermassive black holes at the center, and they were closer to each other than anyone had ever measured before, 1,600 light-years apart. For context, the previous record holder for closest known pair of supermassive black holes was a pair separated by 470 million light-years. That is not a typo. The old record was about 300,000 times farther apart than this. NGC 7727 absolutely shattered the record. The two black holes have masses of about 154 million suns and 6.3 million suns. The bigger one is roughly the mass of the largest known black holes. The smaller one is closer to the size of the one at the center of our own galaxy. They are slowly orbiting each other inside the disturbed core of the merger remnant. Computer models project that they will continue to spiral inward and finally collide in about 250 million years. When they merge, they will release gravitational waves so powerful that if we still have detectors then, we will feel the ripple in the fabric of space-time from 89 million light-years away. They will not be the loudest merger in the universe. Bigger pairs will produce bigger waves, but they will be the loudest one in our neighborhood for a long time. Here's the part that ought to keep you up. The reason we did not know about that smaller black hole until 2021 is that neither one of them is actively feeding. They are not glowing brightly in X-rays. They are not blasting jets across the galaxy. They are just sitting there, gravitationally enormous, almost invisible, in the middle of a galaxy that looks superficially normal. If NGC 7727 hides a 1600 light-year separated pair, then galaxies that look superficially normal can hide them too. Carina Vogel, the lead author of the discovery, said in essence, there might be many, many more of these out there, and we have not been able to find them because they are not making any noise. Most merger remnants in the universe probably contain at least one supermassive black hole. Most of them are quiet. That means the inventory of black holes we know about is almost certainly just the loud ones. There may be a hidden population of supermassive pairs all over the universe, gently closing on each other in the cores of galaxies that look unremarkable from the outside. We can see them only when we get close enough. NGC 7727 is close enough. The next one might be in a galaxy you have been looking at for years. Number 3. NGC 6240. If the last item was unsettling, this one rearranges the furniture. About 400 million light-years away, in the constellation Ophiuchus, there is a galaxy named NGC 6240. For decades, astronomers had been studying it as a famous example of a galactic merger with two supermassive black holes. A textbook case, photographed and rephotographed, used in lectures as the prototype of what late-stage galactic violence looks like. Then, in November of 2019, a team led by Wolfram Kolochny of the University of Göttingen pointed the MUSE 3D spectrograph on the Very Large Telescope at NGC 6240's core and found something that broke a decades-long assumption. There were not two supermassive black holes inside that galaxy. There were three. The team called them N, S1, and S2. N was the previously known northern black hole. S1 and S2 were the new ones. Each of them weighs more than 90 million suns. All three are crammed into the center of NGC 6240, gravitationally interacting, embedded in the wreckage of what is now obviously not a two-galaxy merger, but a three-galaxy merger. The triple intersection somehow brought three supermassive black holes within a few hundred light-years of each other. The reason that matters, really matters, beyond the headline, is what it means about how the biggest galaxies in the universe grow. For decades, the standard story was that supermassive black holes get bigger because galaxies merge pairwise. Two galaxies fall together. Two black holes fall together. You get a bigger one. Repeat over cosmic time. Slowly. Pairwise. Predictably. NGC 6240 does not fit that story. NGC 6240 is three galaxies in a knot. Three central black holes all in one cluster. This is not pairwise. This is a pileup. And if NGC 6240 is real, which it is, then the biggest galaxies in the universe may have grown not by orderly mergers, but by collisions that involve 3, 4, possibly more galaxies all hitting at once. The largest galaxies we see, the ones at the centers of galaxy clusters, with central black holes 1,000 times the mass of the one in our galaxy. They may have built themselves through these messy multi-galaxy pileups, Their cores may have been crowded for a long time. There may have been moments when four supermassive black holes shared a single galactic center, before pairs finally collapsed into singles. Wolfram Kolachny put it bluntly when the discovery was announced. Up to that point, such a concentration of three supermassive black holes had never been seen in the universe. The case provides evidence of a simultaneous merging process of three galaxies with their central black holes, all at once. We are watching it in slow motion. From here, the three black holes appear stationary. They are not. They are gravitationally bound, dancing around each other on orbits that will, over hundreds of millions of years, decay. Eventually, two of the three will collide. Then, the third will collide with the remnant. Or, in some simulations, one black hole gets ejected at extreme velocity, kicked out of its galaxy entirely by the three-body interaction, and goes on to drift through intergalactic space alone. The largest things in the universe occasionally play three-body problems with themselves, and lose. NGC 6240 is not just a colliding galaxy. It is a hint that some of the universe's most colossal violence happens not in twos, but in threes. Number 2. The Sagittarius Dwarf Galaxy. Everything we have talked about so far has been far away. The Antennae, 45 million light-years. The mice, 290 million. NGC 7727, 89 million. NGC 6240, 400 million. Galaxies dying at safe, picturesque distances. The Sagittarius Dwarf Galaxy is 65,000 light-years away. It is right next door. It is, in fact, a satellite galaxy of the Milky Way, and as we are speaking, it is being torn apart by us. The Sagittarius Dwarf was discovered in 1994 by Rodrigo Ibada, Mike Irwin, and Jerry Gilmore. It was hidden in plain sight on the far side of the galactic center, behind a sea of foreground stars, which is why nobody had noticed it before. Once they did notice, the picture clarified quickly. Sagittarius is a small spheroidal galaxy. It has been orbiting the Milky Way for billions of years, and on each orbit, the Milky Way's gravity has been peeling stars off of it. Those stars do not just drift away into the void. They form a stream, a river of stripped stars that traces the path the Sagittarius Dwarf has been taking through the Milky Way's halo. Thanks to the European Space Agency's Gaia mission, we now have measurements of more than 700,000 candidate stars in the Sagittarius stream, a sample 3 times larger than anything previous. The stream wraps around the Milky Way more than once, on a plane that is roughly perpendicular to our own galactic disk. It is the corpse of an entire galaxy, draped over our own. We are watching this happen, not metaphorically, literally. The Sagittarius Dwarf still exists as a distinct, gravitationally bound object. It is still hanging on, but every time it passes close to the Milky Way's disk, more of its stars get stripped away and added to the stream. The math gives Sagittarius a finite, calculable end. There is a clock on it. We can almost name the date. Now here's the detail that makes this item land hard. Some studies suggest that Sagittarius's repeated passes through the Milky Way's disk did not just kill Sagittarius. They affected the Milky Way too. When Sagittarius punched through our disk, it sent ripples through the gas, pressure waves, exactly like the kind that made the Cartwheel galaxy's ring. Those pressure waves may have triggered bursts of star formation in our own galaxy. Some calculations suggest that one of those bursts may have included the formation of our sun, about 4.5 billion years ago. If that is right, and it is still debated, but it is a real published hypothesis, then the galaxy that is dying in our halo right now may have given birth to the system you are sitting in. The Sagittarius Dwarf may be your great-grandmother in cosmic terms, bleeding to death over our heads, while the sun she helped make goes on shining. That is not science fiction. That is just gravity and time And what happens when a small galaxy keeps falling through a bigger one? We see the body. We see the stream. We see the fingerprints on our own star. Look up at the night sky tonight, past the constellation of Sagittarius. Try to imagine in that direction a faint smear of stars wrapped twice around the galaxy. You will not see it with your eyes. Gaia sees it. The mission cost €1 billion and a decade of planning, and it spent most of that effort in the end on this, mapping the dying body, confirming that we are surrounded by the slow, ongoing murder of an old neighbor. The universe is not a still life. The universe is a crime scene with witnesses. Number 1. The Milky Way is the crime scene. We have spent this whole video looking at galaxies hitting each other, out there, across spans of millions of light years, far enough away that we could treat the violence as something other galaxies do to other galaxies, with us watching from a safe distance. That is not actually our situation. About 10 billion years ago, when the Milky Way was young and still growing, a dwarf galaxy slammed into it. The intruder is now called Gaia Sausage Enceladus. The name is awkward because two separate research groups, working from the same Gaia data in 2018, gave it two different names. One called it the Gaia Sausage, because its stars, when plotted on a chart of velocity space, form a shape that looks unmistakably like a sausage. The other called it Enceladus, after the buried giant in Greek mythology. The compromise was to use both. So now we have Gaia Sausage Enceladus. We will just call it the sausage. The sausage was big. By total mass, stars, gas, dark matter, it weighed more than 10 billion suns. It came in fast and at an angle, and it punched into the young Milky Way's first stellar disk. The collision was so violent that astronomers now think it shattered or puffed up our original disk completely. The Milky Way had to grow a new one. Everything we now see as the spiral disk of our galaxy, the spiral arms, the dust lanes, the place where the sun lives, that disk is a second-generation disk. The first one died. The sausage left behind something else, too. About 50 billion solar masses of stars, gas, and dark matter deposited directly into the Milky Way. Those stars did not go away. They are still here. They are mixed in with the stars our galaxy made on its own. But they kept moving on the orbits that they had when they arrived. They came in at a strange angle, with strange velocities, and 10 billion years of orbital motion have not been enough to fully randomize them. Which means today, with a sufficiently good telescope, you can pick them out. The European Space Agency's Gaia mission spent over a decade measuring the precise positions, distances, and velocities of more than 1 billion stars in the Milky Way. When you take those measurements and plot the inner halo stars in velocity space, the sausage population jumps out. They form a long, thin, stretched out sausage shape, completely distinct from the stars the Milky Way made on its own. Their orbits are nearly radial. They plunge in toward the galactic center and back out again, like the strokes of an enormous slow-motion piston on trajectories no native Milky Way star would naturally take. Those are refugees. Refugees from a galaxy that does not exist anymore. They are still on the same orbits they were on when the sausage's core finally dissolved 10 billion years ago. A meaningful fraction of the inner halo of our galaxy, possibly most of it, was originally born in the sausage, then transplanted into us by a single violent encounter. And the sausage was not the last one. Since then, the Milky Way has eaten at least a dozen smaller galaxies. Sagittarius is the most obvious. It is the one we just talked about, still being eaten in real time. But there are others. Gaia data shows multiple distinct populations of stars in the halo, with anomalous orbits and chemistries, each one a fingerprint of a different swallowed galaxy. The Milky Way has been a cannibal for billions of years. We are a galaxy built, in significant part, out of the broken bodies of other galaxies. Think about what that means for the Sun, for your home star. The Sun formed about 4.5 billion years ago, in a stellar nursery somewhere in the Milky Way. We do not exactly know where. The Sun has moved since then, traveling around the galaxy. But every star around it now is essentially a stranger. Every star within visual distance from our Sun was either born somewhere else in the Milky Way, or possibly born in a galaxy that no longer exists. When you look up at the night sky on a clear night, most of the stars you see were born in the Milky Way. A few of them may not have been. There is no clean visual way to tell which is which. They look the same. They burn the same. But some of them are immigrants, brought here a long time ago, on the day a galaxy died. The Milky Way is not an object. It is a graveyard, still settling. Most of the dead are quiet now. Their stars have spread out, their gas has mixed in, their original shape has dissolved. But they are still here. Their atoms are in your body. The iron in your blood was forged in supernovae that happened, some of them, inside galaxies that the Milky Way later ate. We are made of winners and losers. The winners shine in the disk. The losers shine in the halo. And there is no third option for galaxies in the universe we live in. Either you eat or you become someone else. Tonight, when you look up, just remember, you live inside the body of the thing that ate the other ones. The Sun is not floating in empty space. The Sun is moving through a graveyard, and every once in a while, the graveyard moves with it. Thank you for watching and sticking till the end. We've got plenty more videos coming in the future. Hit that subscribe button so you don't miss them.